Hello, this is Unit 1, Lesson 1, Day 2. This is the warm-up that we had for this day. It was all solving the equations with variables on both sides. As you can clearly see, I've already solved all the questions already. Just quickly going through them, we have subtraction property of equality, get the variables on the same side. I've always moved the one that's smaller. It tends to be the easier way of doing it, so you don't have to deal with negatives. So I moved the 5x, so that's why I subtracted 5x from both sides. That gave me the 2x, and I added 17 to both sides, so I could have this and divide both sides by 2, division property equality, and got an answer of x equals 5. So you can clearly see on question 2 and 3, I moved the one that's smaller. Negative 2x's is smaller than 3x's, that's why I moved it first. That gave me 5x on the left-hand side, and I solved it like a two-step equation, so I got x equals 7. On the third one, I also moved the one that was smaller first. I moved 1x, which is smaller than 3x's. That made it easier to solve as well. And I got an answer of x equals negative 2. So this lesson is the second day of checkerboard borders, and in this lesson we are now opening it up to this idea that, well, what if the center square is any size? It doesn't have to be 2 or 3 or 4 or 5 or 6. It could be 100, could be 1,000, could be 1,000,000. So what if it was any size? So we have to imagine, well, what would that look like? Well, we don't know how many blocks are in between, so that's the reason why this is left empty. And in class, we had a long discussion about the fact that this is the same as S, because whatever length this inside block is would be the same amount of shade tiles that's in this space. Whereas this, if I circle this, it would be S plus 4. And the reason why this one's S plus 4 instead of S is because it includes the two corners. There's two squares in each corner, therefore making S plus 4. So using that logic, then students in their groups were able to come up with their own strategies. For instance, they could say that this is S plus 4 and that this is S plus 4 and that the two sides are both S. And then when you put that together, you've got two groups of S plus 4, and you've also got two groups of S. And then you're going to include that plus S, so you got your expression. So that's 2 times S plus 4 plus 2S. Whoops. 2S, because there's two sides that are both S. There are other multiple ways in order to solve it. Sorry. I told you I'm not going to edit anything, so we got a little mistake here. Going to solve it any different ways that they'd want. And so you get to the homework. When you get to the homework, a lot of questions I got asked about this. When you solve this, 1 ends up standing for the number of blocks in the very first step. Number of blocks. Okay, I'm having problems with the writing utensils, so I'm just going to have to say basically what everything means. So the 1 represents how many blocks are in the very first step. 3 represents how much is being added to each one. So as you go from step 1 to step 2 to step 3, it's always a pattern of adding 3. And n minus 1 is actually something we haven't done yet. It's called a recursive formula, and n minus 1 is the previous term. So that's what the n minus 1 comes from. That's going to be something we're going to do in the future. Number 5 is an explicit formula, so this one's a little more straightforward. 3 represents, once again, how much is being increased each time, but the negative 2 is the 0th term. So if you go backwards, you got 7 blocks here, then you got 5 blocks here, and then 1 block here. Oh, nope, that's not the right numbers. It's actually 1, and then 4, and then 7. So you will notice that the pattern is increasing by 3 if you go up, but if you decrease going down, you'll notice when you get to the 0th term that it becomes negative 2. So that's what the negative 2 comes from. Hope this helps. Please just come see me in the morning if you have any other questions. Thank you very much. Have a good day.